let's talk about numbers. When you were little and you first learned to count, you started with 1 and counted up. 1, 2, 3, 4, etc. A little bit older and you learned about 0, maybe because a sibling took all your toys away. And we have the whole numbers, 0, 1, 2, 3. Older still, maybe you're learning about money, owing, borrowing, earning, and you get the integers, the negative whole numbers and the positive whole numbers, zeros in the middle. And yet again, a little older, learning about fractions, decimals, how we can write fractions as decimals, and we can write decimals as fractions. And then geometry happens, and we learn that not all decimals can be written as fractions. We learn about pi in relationships with the circle. We learn about square root 2 with triangles and square roots. That number e we are going to explore a little bit later on in this course. But all of those groups of numbers together make up the real numbers. Rationals and irrationals, where the rationals encompass the integers, integers encompass the whole numbers, and the whole numbers have the natural numbers in them. But we encountered problems. When we tried to take square roots of negative numbers, we can't. The real numbers alone will not allow us to do this. There is no real number that when I multiply it by itself, I will get a negative number back. So in order to expand our thinking, we're going to define a new number. And this new number is called the imaginary unit. The square root of -1, we are going to define using the letter I. A small disclaimer, physicists and engineers tend to use the letter J instead. So just know that if you're reading a physics book or you're looking at something written by an engineer or written for an engineer, you may see J representing that imaginary unit instead of I. But mathematicians, we use the I. And I expands our number system. Instead of just being stuck in the real numbers, now the real numbers are a subset of the complex numbers. Notice how the real numbers are written 0 times I. We only have what we are aware of as the real numbers. We can see over here the pure imaginary. This would be some number times that imaginary unit. And notice they say A equals 0. And then imaginary numbers, 2 plus I, for example, here. All of these numbers together make up the complex numbers. The A in the complex numbers is the real part of the number, and the B is called the imaginary part. One thing that is unfortunate about imaginary numbers is their name. The complex numbers have a really rich history, so if you get a chance, try to look some of that up. But it was thought when these numbers were discovered that they did not have a purpose in the, quote, real world. And so that's how we get this imaginary name. But complex numbers are far from imaginary. They have real-world applications. They do exist. And they are vitally important for so much of mathematics. So the idea of imaginary in math does not mean made up. We're repurposing that word for something else, just to give a name to a group of numbers. And here we have, by definition, I is the imaginary unit. I equals the square root of -1. So if we square both sides, I squared is -1. And we have this property, if a is positive, then the square root of negative a equals I root a. Let's break that down a little bit. Square root negative a equals, we can write this as negative 1 times a, just like we can with any negative number. The radicals let me break apart over multiplication. And here I have that square root of negative 1 that we would call I. So for the next problems, try rewriting each of these square roots using the imaginary unit instead of leaving the negative under the radical. And if you can simplify the numbers more, you want to do that. Pause the video, try it on your own, and come back and check your work. If you make mistakes on your notes, don't erase them. Use a different color marker or pen. Go back and edit. Make notes of your mistake, maybe why you made them, so that you can learn from them. Let's take the first problem. Square root negative 36. I'm going to use this property right here. The negative is going to come out as an I. Exactly for the reason that we just wrote up there. We could do these steps every single time. Square root of negative 1 times square root of 36, I square root of 36. But we can also use this property, now that we've proven it for every value of a, positive a. Let's just take that negative 1 out and turn it into an I. And then the square root of 36 we know is 6, and we like to write the coefficients in the front, so we have 6i. We can do the same thing for 2, I root 15, but 15 has no perfect squares in it, so there's not much we can do there. For number 3, square root of negative 45, we can bring the negative out as an I. 45 is also 9 times 5, and the square root of 9 is 3. So we can have 3i square root 5 for number 3.